Hello guys, today we will start another beautiful problem. Okay guys, so look at these problems. Two bodies were thrown simultaneously from the same point, and one is straight up and another one is at an angle 60 degree. Is it okay guys? Now, and the initial velocity is same. Okay, that is v naught is equals to 25 meter per second, and we have to neglect the air drag, air resistance. Okay, and we have to find out the distance between two bodies at t is equals to 1.70 second later. So always remember this guys whenever you see these type of problems. Okay, two bodies with different velocities, so we will always use this approach. Okay, and that is relative velocity concept. Okay, so in which what we have to do, in which we will stop one body and we will, okay, and that velocity we will give to another body, or and now further we will solve it. Okay, so look at this problem, very important. Okay, this is another beautiful problem. What guys? Okay, the first body guys, this is the initial point. Okay, the first body is straight up. Okay, suppose that this is the body 1, this is the body A. Okay, he is going upward direction with velocity v naught, same velocity, and the another velocity, the another body is going in this direction. Okay, at angle theta. Okay, at angle theta, that is equals to 60 degree. Okay, this is the body, suppose that this is the body B. Is it okay guys? So here you can see, so now what we have to do, we will see this motion, we will observe this motion. Suppose that I am sitting here. Okay, I am sitting here. Okay, at ball B, and what I do, I will give the okay, what I will do, I will stop A. Okay, and this velocity is also given by B, or we will further we will okay, study this motion. So first of all I give this negative velocity, that is v naught. So now A is stop, same velocity is given to B. Okay, that is v naught. Now we will use the relative concept, relative velocity concept. So now we will use the second equation of kinematics, and that is equals to, we know S is equals to ut plus half at square. Is it okay guys up to here? Now what we have to do, we will use this for relative velocity. So here this is the displacement. Okay, and that is equals to u naught initial velocity into time plus half their relative acceleration into time square. Is it okay guys up to here? Now look at this, I can write down this as relative, this is the relative displacement. Okay, minus this is the delta, so this is final minus initial, or this is initial point. Okay, 412. Is it okay guys? Now what I'm writing down here, you can see the acceleration, relative acceleration. We know for this body the acceleration is downward, that is minus g. I am taking downward direction is negative. Is it okay guys? Or for this body, the again the acceleration minus g, so the relative acceleration will be 0. Is it okay guys? So this terms will outcomes to be 0, and we know the initial position, they are starting from origin, from same point, so this will also be 0. So the distance between these two particles at time t, that will be equals to as the relative distance, that is equals to the magnitude of their initial relative velocity. Okay, into time. Is it okay guys? Now the time is scalar quantity, so we can write down this in such a way. So this is the task. If we find out this value, so we can solve this problem easily. So now guys, that their relative velocity, okay, so this is the relative velocity. Suppose that this is the relative velocity of 1 2, or we can say, here I am assuming AB. So this will be the initial velocity of A and the initial velocity of B. Is it okay guys up to here? Because the velocity is vector quantity. Is it okay guys? Now we know the magnitude of these two velocities at these two velocities, that is v naught, okay, initial velocities. So now I am writing down this v naught minus v naught, but their direction is different, okay, their direction is different, okay. Or we have already earlier discussed that we have to give the negative velocity to the to the body A, okay. So this is the final, okay, this this is the final expression, and the vector diagram that is in this way, okay. Here we can separate. Suppose that this is the velocity A, this is the velocity v naught. This is v naught for body B, this is the v naught for body A, okay. This is the diagram of this expression, okay. Now how we solve it? We know the angle between these two, that is theta. Theta is equals to, now guys, this is 90, this is 60, so this will comes out to be 90 plus 60, 150, okay guys. Or we can write down pi by 2 plus pi by 3. I am writing down in this way, okay. So, or we can write down this theta is equals to pi minus pi by 6, okay, 180 minus 30 degree. So we will use direct concept, okay. So either we will use this, or either we can use directly. Otherwise, to solve this we have to take negative, okay. So we have already taken this. So now if you use the formula of subtraction of vector, so then you have to take minus sign. Otherwise you can directly take as a addition. So I am here directly taking as addition. So guys, listen carefully. I am writing down this expression, okay. The magnitude of this will be u naught 1 to magnitude is equals to under root, because we are taking the magnitude of two vectors, okay. So we negative sign, we have already taken negative vector, okay. This is minus v naught, okay. Actually this is not, this is minus v naught, okay, because in this opposite direction. So we have already taken the minus sign because we converted the direction of A. So we now we have directly used the addition, or that will be v naught square plus v naught square plus 2 v naught, because their magnitude is same, and the angle between cos theta, the angle between these two vectors, that will be cos, and the angle is pi minus pi by 6. Is it okay guys? Now we know the cos pi minus theta, okay. In second quadrant the cos will be negative. So if we will further solve it, that will be comes out to be 2 v naught square minus, that will be 2 v naught square, and cos pi by 6, cos 30, that will be root 3 by 2, or here will be negative sign will come. So here root 3 by 2, okay guys. We will take v naught outside, so this value comes out to be 2 minus root 3, okay. Is it okay guys? Up to here everything is clear. Now guys, look at this. We already know that is 25 meter per second. Now we have to calculate the value of this relative distance, okay. So we know the value of their initial relative velocity into time. So the relative distance, that will be equals to, here the velocity is 25, or this is root 2 minus root 3 multiplied by the time, that will be 1.5. 7 second. Is it okay, guys? And that will comes out to be approximate 22 meter. Okay, guys, that will be comes out to be 22 meter. Is it okay, guys? Thank you so much.